present here. Today, I, Deblina Ojha of Class 9G RPRI, is going to present on the topic of linear Hall effect sensor. So the first question that arises in our mind is, what is a linear Hall effect sensor? A linear Hall effect sensor is a transducer that varies its output voltage in response to a magnetic field. Hall effect sensors are used for proximity sensors, positioning, speed detection, and current sensing applications. In a linear Hall effect sensor, linear or analog sensors give a continuous voltage output that increases with a strong magnetic field and decreases with a weak magnetic field. Here is the picture of the linear Hall effect sensor. What is the working principle of a linear Hall effect sensor? In a linear Hall effect sensor, a thin strip of metal has a current applied along it. In the presence of a magnetic field, the electrons in the metal strip are deflected towards one edge, producing a voltage gradient across the short side of the strip. Application of linear transducer. They are used to measure the magnitude of the magnetic field. These sensors generate a high voltage when a magnetic field is detected, which is used to measure the magnetic flux density. This diagram shows the connection of the linear Hall effect sensor with Arduino. The Arduino Hall effect sensor code can be used to detect a magnet and count the number of times it detects it. This Arduino detects the interrupt pin 0, digital pin 2 of the Arduino. Whenever the Hall effect sensor detects a magnet, it outputs a high voltage, about 5 voltage, to its wout pin. In this way, the linear Hall effect sensor connected to the Arduino works. What are the applications of linear Hall effect sensor, or where they are used? They are used for position sensing, anti-lock braking systems, disk drives, keyboard switches. This diagram shows how a linear Hall effect sensor works. A magnetic field is detected through which the linear Hall effect sensor would start working. What are the advantages of using a linear Hall effect sensor? Make by chapter. They have high speed operation, they are highly reliable, they have the ability to work in a wide temperature range, they offer pre-programmable and electrical angles and outputs. There are also some disadvantages of using linear Hall effect at a distance which is more than 10 centimeters. Sir, can you see my screen?
Yes, I can see.
Okay. Yes. So, there are also some disadvantages of using linear Hall effect sensors. They are not able to measure a current flow at a distance which is more than 10 centimeter. The accuracy of the measured value is always a concern, as external magnetic fields may affect the values. High temperature affects the conductor resistance. Thank you everyone for your patient hearing.
Very good, very neatly presented with very good communication skills. Nice. Audience,
Thank you,
if
sir.
you have doubts, you can.
I have a question.
Yes, sir.
What is magnetic flux density?
I will go to that slide and then I will explain to you. Yeah. The magnetic flux density mentioned here is the amount of magnetic flux in an area taken perpendicular to the magnetic flux density. An example of magnetic flux density is a measurement taken in Teslas. Can I make it clear to you?
Yeah,
Okay, thank you.
Good. Any other place?
Any more questions?
I have another question. In this slide, in the first paragraph, last line, you wrote that across the short side of the strip. What does this phrase mean?
Can you repeat the question?
What does this mean that across the short side of the strip? In that slide only.
This one?
No, where the magnetic flux was written.
This one?
Yeah, first paragraph, last line.
Okay. The electrons in the metal strip are deflected towards one edge, producing a voltage gradient across the short side of the strip. It will produce a voltage gradient that is of 5 volt across the short side of the strip. That is in the short side. So it will produce a volt there only.
Okay.
Thank you. Any more questions?
Any more questions from audience? Okay.